Hi friends, my name is Ignatius K. Pius and I'm doing my ME final year in Tech Multitech Engineering College, and the title of my project is Improving the Spectrum Aware Mobility Management Concave Radio Networks. So this is what my project is based upon. So let me tell you before explaining about my project. It's quite a long process, so before I explain you how my project works. So first I go to applications with accessories where I go to files, and in this files you find a folder like documents, and I'm getting into the documents folder, and this is where my entire documents are stored in and efficient the final document. So I right click, I'll copy the path name, and I open the turbo for compiling process. So it's the terminal, I have opened it. So I give cd space and the file name, just I'm pasting the file name over here. I give an enter, and this is how it runs, and I'm now into a file name where I find a list of process. So this is what I have done with the caps of using app and enter. You find it get booted up and joining router where you find the virtual transmissions. So in my existing system, which are done by 25 nodes, and this is what a path of 25 nodes carries on. So let's give a time. It takes a few times how this 25 nodes are carried on with the process. While the combining process, I could like to tell you, like, in this in the existing system you find loss of data losses and other things that happens. So it's quite loss in this. The main theme of my project is like sending from source to destination, like from one point to other point, sending the messages without any loss of data, and and this based on user requirements. So it's all totally based on channels which I'm using it. So if you see the software requirements, there are quite softwares and hardware requirements are required in this. But before that, let me go to routing simulations, what it is done. So this is the routing simulations, and this is how it takes place. So in this we find one source and three destinations, from one source to three destinations, how we are sending a message, and what are methods and what are the losses that takes place. This is called a double coverage broadcasting system which we are using in it. So this is a source and this is the three destinations, and from source to three destination it tries to move on. So this is what happens here. So it's finding out the path, the shortest path to send, and it takes a much longer time. So I'm ending this up right now. So this is my existing, and this is what happens. So based on the present which I've told that I'm using 50 nodes for this, and it takes a couple of time to load it. Meantime, I'll tell you the software requirements that I'm using in this. Like, it is, of course, it is based on C++ compiler for the Linux, and I'm using the TCL compiler, which is tool compiling language in this, and I'm using NS2 tool which we have seen writing right now. And the other OS which I'm using is Linux OS, which I'm using through the help of a virtual machine. So this is how the Linux OS works. The hardware requirements, you just have to require minimum of 20 GB of your hard disk and above, the RAM of 512 MB above, the process which we can have minimum of Pentium 4 and above. So it runs in the basic softwares and other applications. So in this you find a 49th node that is called which takes place from 50 nodes. It starts from 0. So this is the compiling process takes place, and of course since it is based on 50 nodes, it takes more time compared to 25 nodes, and this is what I have to comment. So let us give some more time for this. And about the NS2 tool, we can tell NS is a version 2 tool. It's an object oriented discrete event drive network stimulator development at UC Bakers, written in C++ notes TCL language. So in this, NS is a primarily used as a simulating local and wide area networks, although NS is fairly easy to use once you get to know more about the simulators. And if you find if you just have to listen to the overview, it is like NS is event drive network simulation developed in UC Bakers, as I said earlier, and its behavior as FTP, Telnet, Web, CBR, VBR, routers, queue management mechanisms such as drop, tailread, and CBQ. So this is a method that takes place in NS2. And let us give some more time, and let's see how long it takes for sorting out these 50 nodes. it is like around 5 minutes 10 seconds over for this, and we are still on the loading process, and as said, it's quite a long process. Now this is what the routing simulation for the present, that is the current scenario which I made a project, and in this we are doing with 3 source and 3 destinations, which is quite a good thing. And this is how it works. So this is what, like, source 1, source 2, source 3, source 2, source 3, source 3, and source 4. Like, you find source 1 with destination 1, source 2 with destination 2, and source 3 with destination 3, and what are the path it goes. And it is based on mesh networking technology, that is called Delay Optical Broadcast and Multi-Hop Wireless Mesh Networks. And the virtual machine which I'm using, it is Oracle VM virtual machine, and this is what the source to destination, how the messages are sent, and it's quite a longer method as I said earlier. So I just want to go for the comparison process right now. This is what the compilation process goes, and first we have to compile the existing and the present which projects have done, because we have to compare it with the graph. So it takes a quite amount of time for the transfer details to take place. So almost the compiling process is done. So first we find for the delay ratio, compiling is not done properly. So this is the compilation process which are getting compiled with xgraph 1 and xgraph 2. So it takes a little more long timer. So in this you find the existing and the present. So by comparison, this is how you find the x-graphs, the compilation takes place. So in this you find the existing is green, and existing is the red one, and present which project have done is green. So this is how its comparison is going. So first we saw the delay ratio and the total loss. In this, if you find the existing has more loss compared to the my proposed system. So when you're doing a comparison, you find the lossage, how it is overcome, and this is a more loss takes place, and this is the less drop down less. So meanwhile you found for the throughput load workload 2. So this is how the workload graph works on. This is the existing workload graph, and now we're looking into the present workload graph in this. Now this is the present, and now we are going to compare both. So in this you can understand like how the workload can be given more in my present project compared to the existing project which has been done. Same way there are many things. So the main thing of this is the application process which we are going through now. In this application process we are using with the source and destination method. So first we have to choose a destination. So this is a destination which we have to open it. Without choosing a destination, one cannot go for the method. So this is a source. From the source we are choosing it using a login and giving my username. Yes, the username is given. So it is destination has been recognized. So now we are planning to give a message like, for example, we are giving us thank you. So this goes to the destination, and let us see whether it has been received. Yes, in this you find thank you, and this is the different part of 50 notes which is undergone, and finally it reaches the destination. So this is all what my project is about, and do comment below if anything have any doubts and other things. So thank you for watching this, and have a great time. Thank you.